Right, so we're looking at backward probability trees. There is a particular kind of problem, and they can be a little more complicated than this one, but this has got all the ingredients. You're given an overall probability, but you've got information missing on your tree. Can be a bit disconcerting. I've got the tree drawn up in this case. So my example is a football team is known to play better at home. Their chance of winning at home is twice as good. And there will be some kind of condition like this built in. So that's probably worth noting. Okay, because we're going to use that when they're winning away. They play away 60% of the time. Now that 60% allows us to fill out the first part of our tree completely. And they win half the time. The problem with that is that win half the time is a combination of two branches. So they could win when they're away, or they could win when they're at home. And we've got this twice as good probability, or twice as much. So we say whatever their chance of winning when they're away, it is double when they're at home. So that stands for an unknown, that stands for twice of it. You can use whatever symbol you like. I used a question mark to avoid the double up. So I know that 0.6 times my question mark is one way I can win, winning away, plus 0.4, 40% home games, but twice as likely to win. That's the other way I can win. So to find part A, the probability of winning at home, and now I'm going to just uncover my work in here in one go. I think that's going to be simpler. I had more complicated plans. Okay, so this part I'll put back in red because it was in red. That's the bit that we were originally given. Okay, so the probability I win when I'm away, still got an unknown in that, still got an unknown in that. Might be good manners to copy and put a times there. Okay, so, but I know when I combine those two it equals 0.5. This is very solvable. 0.6 plus 0.8 that I got from there gives me 1.4 times this unknown question mark. Still totals that 0.5. The 0.5 hasn't changed. And then I do a quick division and I get this. Now this is the value of my question mark, which is the probability of winning in an away game. We've been asked to find the probability of winning at home. Now winning at home is twice as likely, so I double that and I get that. So that is my actual answer, okay? The second part to the question, so that is the working in reverse. So I've multiplied out, I've used a placeholder or a variable there in the meantime to allow for the unknown. I've used the overall probability, which was the 0.5. That line there is the key line of working. Once I go on to part B, this is just conditional probability with nothing special. If you're doing this at level 3, they might ask you just to jump straight in and do part B. At level 2, I would expect them to ask you to do part A separately, just because it makes it a little bit more simple. So probability that we're playing away, given that, that's that doofer, we have a win. Now, that would be the probability we're away and win over the probability that we win. Now, the probability we win is the 0.5. It's been there all along, so we're not going to reinvent the wheel. We're just going to put 0.5 on the bottom line. On the top line is part of that 0.5, which is that 0.6, the chance they're away, times their chance of winning while they're away. If you roll that all through your calculator, you get the close to 43%, and that's your final answer. Okay, my phone's just annoyingly gone. I'm going to close it off there.